Hi, all. Alright, so what I'm going to do is just run through the introduction to differentiation for you. And then in the next video, I will do an example of differentiation by first principles or difference quotient. Alright, so we have a good amount of things to cover because I'm not looking at these in the video and I'm reading. You see the point of how much we have to cover. Alright, so differentiation, it's the process of finding the derivative of a function. What is the derivative of a function? It is the slope or the gradient, the steepness of that function. Right? So if we're looking at the gradient of a curve, well, yes, if we're looking at the gradient of a curve, then at every point on that curve, the gradient is different because it keeps the line keeps changing direction. For example, if you should look at the graph of y equal x squared, then you will see that the gradient is constantly changing as you move from point to point. Differentiation, alright. Differential calculus is an important tool of mathematics that has applications in disciplines such as economics, engineering, science. It deals with finding the rate at which one variable changes in respect to another. And your duty is to research other practical uses of differential calculus. That's on you. So as I said before, derivative of a function is the gradient of the function at a particular point. If there's a point of discontinuity, there is no gradient at that point. At the cusp of the function, there is no gradient at that point. Where there's a vertical tangent line, there is no gradient at that point. Now, you can differentiate a function more than once. And so the first one is what we call first derivative. And it is denoted f prime of x, dy by dx, y prime, or f to the 1 of x, which is still f prime. Alright, so if it's second, then it's f double prime d squared y by dx squared. So the 2 is referring to second derivative, right? Y double prime f to the second power of x. And whatever so far you go, the end derivative, that's what you will have in these places where the changes take place. Alright, so we have differentiation by first principles, and that is when you choose a point to find the gradient of, and you choose another point that is so close to it. The fact that it's gonna be so close to it makes these 2 points have the same gradient because they're so close. Alright. So given the curve y equal f of x, we can calculate the gradient of the tangent line at the point A, where x is c, or you can just use x. Right? So let's say this is our point A. Here's the x value. The point B is very close to it. So this is actually a representation of the magnification of point A and B, so you can see, right? But they're really, really close. And we call this next point, the distance between them, we call it h. Or yes, the distance between them, we call it h. Now, how do you find the gradient of a line? From Bright Sparks, physics table. Oh, it's right there, isn't it? So that's gonna be y2 minus y1 divided by x2 minus x1. So looking at our graph, we would have b is our y2 and a is our y1, right? So we would have f of x plus h minus f of x. So this is the y2 and this is y1. And in this case up here, remember we said x equals c. So it would be c plus h. That's where we get the c plus h from. But you will see either of these. You can see it as c plus h with c, or x plus h with x. Alright? So in the case right here where we have that, y2 would be f of x plus h. I don't like this pencil. F of x plus h minus y1, so that would be f of x, all divided by x2, so x plus h minus x, right? And this is called a difference quotient, and this is what we use to differentiate using first principle. And I soon show you what I'm talking about exactly. So see that I went there. Differentiation of powers is simple. You multiply the coefficient of x to differentiate a power. You multiply the coefficient of x by its power and reduce the power by 1. So for example, you are given the function f of x equal 3x squared plus 25x. It says to differentiate x to the n, multiply the coefficient of x by its power and reduce the power by 1. So here's the coefficient, right? Power. So that would be 6. Multiply coefficient by power, reduce power by 1. So that would now become, call it that we're looking at sum of differentiating sums, right? Same principle, I did not differentiate this a while ago. Power here would be 1, so that would be 25. Reduce the power of x, so that would be x to the 0, which is 1. 25 times 1, 25. So we just differentiated an example. Did you see it? You can write that off. Let's do another one. Let us look at differentiate this, right? First thing you do is get it out of the fraction form. So we know that we should be able to rewrite this as x to the negative 5, laws of indices. Then we differentiate, so multiplying by the coefficient, we get negative 5x. Decrease this by 1, becomes negative 6. Remember, the higher up you go on the number line, is the smaller the number gets, right? So if you decrease negative 5 by 1, we're moving up to negative 6. But really and truly, we're moving down to negative 6. Alright, so in the next video, we're going to look at differentiation by first principles. Until then, I'll see you